So this is going to be our video clip on columns. So we're going to kind of talk about columns and their sizes and some other features of them to start. So you can have really big columns. This column's probably 1 meter long and it's about 50 millimeters or 5 centimeters, about 2.5 inches wide. You can have much thinner ones like this one, and kind of anywhere in between. And so the width and the length of the column varies a lot, and kind of the key point of that is if you have a lot of compound, you want a wider column, and if your separation is really difficult, you want a longer column. So for whatever scenario of chemical separation you have, that kind of dictates the size, both the length and the width of the column that you want to use. And that would be kind of stuff you'll have to figure out on your own. For a new thing, or if it's an existing prep, you could possibly find that information available to you. Some columns have frit, so much like the funnels you might be familiar with. So it's a porous glass part at the base. These are very nice for doing columns. They kind of make one of the steps of setting up a column easier that we'll get to. Other columns like this one don't have one. They just have a straight, kind of the funnel bottom part. So here's another version of the column with a frit to it. So you'll also notice that columns might have different types of ends. So this one just has a rolled kind of like a beaker top end. This one has like a rounded socket end. This one here has a 2440 ground glass joint. You might have other ground glass joint types. So these are all for different applications. This type is a gravity column only, meaning that you can really only use this to perform a column under just normal gravity. Ones with ground glass joints can be used in conjunction with an adapter here to connect them to air. Hose. So connect it this way. Couldn't get around before. So you can connect a connector like that, and you can push air through the column, which will help. That's something called flash chromatography, or doing a flash column. So you can use air pressure to help force the solvent and your compounds through the column, speed up the process a little bit, but it has other things to be concerned about. The kind of column that has this rounded bowl-shaped joint is for attaching a solvent reservoir. So you'll see that this joint fits here, and then the clamp can go over it. So that's just in case, or a different version of this type with the solvent reservoir that's part of the column, the entire thing. Those are just convenient for running larger columns where you want to, or a longer column perhaps, where you need a lot of solvent, you want to fill it up and be able to run it like that. So yeah, there's a lot of different kinds of columns, and depending on what you need to do, really dictates what type of column you're going to set up. So I'm going to demonstrate now kind of how we set up kind of just a basic silica column. So I've got my column picked here. This one was probably 15 millimeters, maybe 20. Anyway, it doesn't actually say on it. I wish it did. Anyway, but this one doesn't have a frit. So this is where we're going to have to show you what to do with a column that doesn't have a frit, which is probably the greater case. So what we need to do is pack this thin portion of the stem here in front of the stopcock portion with some cotton. Glass wool also works, but I know that cotton will be okay for this application. Glass wool is a little bit harder to pack into space like that, so that's going to be too big. So kind of getting the right amount of cotton is a bit tricky. So that piece, that's just a bit small. So that would probably be about right. So one of the best ways is kind of roll it to get a nice little sort of pill-shaped piece approximately. You can hold it in place with some tweezers. And then take something long and thin, like a thin spatula, this little pokey wire bit that we've got here. Some wire itself works, some stiff wire works well as also. Push that into that stem area, and that's not enough cotton. I can feel I don't have enough resistance when I'm pushing on that, so I can tell that I don't have enough cotton. You'll have a bit of resistance when you're trying to push that bit of cotton or wool into that narrow portion of the stem. So let me turn this around. Actually, no, it's working better the other way. I'm just using the tweezers to hold that gently in place. There we go. Oh. See there, I've just about pushed it. In fact, I pushed that too far in. So let's push that all the way through again, retrieve it, try again. Doesn't want to come out, staticky. So, just kind of hold that there with the tweezers. Wad it up a bit more. I'm not getting any resistance to push it in with. Alright, now I gotta do this part slow, but don't push it too far. That should do it. There we go. So you'll see we have the cotton where it just fills this stem area, so it doesn't have any poking through into the part where the stopcock will go, and there's barely any poking out above the stem there. You could possibly add a tiny bit more there, but I'm going to go ahead and use that how it is. So now we'll want to install our stopcock. Our Teflon stopcock, locking ring, gasket, O-ring, and the nut. Make sure I get that on correctly. Cross-threaded. Okay. And we want that to be tight enough that we can turn this, but not so tight that it's really difficult to turn, and not so loose, of course, that it will leak. So, now we're ready there. So now we can go over to our hood and clamp our column up. It's very important that when we clamp up a column, we do it with 2 clamps. This just gets us a better amount of stability. It prevents the column from being able to wobble forward or back or side to side. And especially if you're doing larger columns, they can get quite heavy when they're packed with your material as well as full of solvent. And if you don't have enough clamps, they could fall out of the clamps and break, and that's obviously a bad time. So, there we've got our column nice and clamped up. So the next thing we need to do is this bottom kind of bowl or dish or cone-shaped portion of the column, since it doesn't have a frit, will cause problems for our separation at the end. We want the end of the column to be flat. So to kind of fill that gap, we're going to put a little bit of sand on top of that cotton plug, and that's what the cotton plug is for, just to retain the sand and the silica so they don't just come spilling out of our stopcock. So I've got here some lab sand, and I found the easiest way to do this is to get a little bit in a beaker. It doesn't take a whole lot. We got a pretty small column here. Get a nice dry funnel. One of the longer stem is nice, especially when you're using a column with a solvent reservoir, so that you don't have sand particles sticking to the part up here in the solvent reservoir. That's annoying to get them out. And we'll just kind of sprinkle in a little bit of sand until we get them out we want. We can tap on the column a little bit to get it to settle. See, even now it's sticking up here a little bit. Well, you might not be able to see that, but I can. Let's add a bit more sand. Okay. So, let's look at that a little bit closer. So, I think we're just, or maybe just a little bit short still. See, in the back, it's not a very even layer yet, and in the back, it's got a low spot. So, here's where we would need to add just a bit more sand. We want a nice flat layer. We don't need to go clear up into the kind of cylindrical portion of the column, but right to about where it starts. So we're pretty close, just a bit more sand would be just what we need. So yeah, that looks really nice right there. Keep our funnel out. Actually, we can leave that funnel. All right, now we'll move on to getting the silica preps to pack the column. So before we can pack our column with silica, we need to make up our solvent mixture. So the solvent mixture we're going to use with this column is a solution of 15% ethyl acetate, with the balance being hexanes. So I've got ethyl acetate here, and I'm going to make 400 milliliters of it in this 500 milliliter graduated cylinder. So that means I need 60 milliliters of ethyl acetate, and then the rest up to 400 will be hexanes. Quite there, just about. Perfect. And I've got a large bottle of hexanes here. And there we are, filled up to 400 milliliters. It's good also to have a layer of solvent on top of your sand. That will help prevent the sand layer from being disturbed as you pour in the silica. It's important though to still pour things in slowly. A long stem funnel kind of pointed at the inside of your column helps as well, if you have one with a solvent reservoir. For the straight walled ones, pouring down the sides can help. So that's So now to show how to get the silica into the column, take a beaker, and we want about twice as much solvent as we do silica. So I'm going to add, just from my bucket of silica here, it's like half a scoop. I've already got a scoop in there, so yeah. So that's filled it up to about the 25 milliliters, so we'll add double that. So we'll go up to the 75 with some solvent. So I've got some solvent here. That wasn't quite enough. We can kind of tell that because if you're going to stir this, it's pretty difficult to stir. So that means we don't have enough solvent there. Obviously we can't pour this. So to fix that, we'll add more solvent until we get a mixture that is pourable. There we go. That's quite thin now. It almost feels like just unsolvent. So, and then we want to pour this in slowly so that we don't disturb. When you start especially, you want to pour it in slowly so you don't disturb your sand layer. And then you can see this kind of looks like it's all one thing, but you'll see that it slowly will kind of start to clear up at the top, and then it will move down as the silica settles. And that's what we want it to do. And that will give us a nice tightly packed column if that settles nicely. Again, here's where we can implement the use of our rubber hose to tap things. That will help get some of the silica out of up here, as well as help it settle a bit faster. Close. I wanted a pretty good length of silica, so this should be about right now. So now that our silica has settled and we've got what looks like a pretty flat layer, we want to protect that flat layer. So we're going to do that by adding just another layer of sand. So first I'm going to rinse out, put a little more solvent in here to rinse down these little bits of silica that have kind of stayed up in the top of the column. To do that, I'll just pour in just a little bit of solvent. If you do this right, we'll just kind of pour around the inside of that circle. Perfect, just like that. And we can give it a few taps with our hose here. And that will settle that last little bit of sticky silica. I'll take our dry funnel again and really carefully sprinkle some sand to get another layer of sand. And we want probably half an inch, maybe a little bit less, between a quarter and a half of an inch of sand on top of there. Half an inch might be a bit of an exaggeration. Yeah, something like that. And that kind of amount, yeah, about a quarter of an inch, maybe a bit more. That should be enough sand to protect our nice flat layer of silica. Okay. Now the next thing we need to do is, before we add our load, put a flask under here for collection, is we need to drain the solvent down to the sand layer. So I'll begin that process here by opening my stopcock to let the solvent start to drain out. In this case, I could use my adapter here to push some air and push that through, which I might do. Yeah, we'll just go ahead and do that. It doesn't take very much air if you're doing this kind of a thing, and that's probably a bit of a strong flow even. Really gentle hiss, and then you want to hold this because the amount kind of that you push in will determine kind of the pressure that you get, because you want the air to be able to escape. Otherwise you could blow this adapter off and have it swing and break. We don't want that. Stop there. I'm going to stop there because I want to, I can see that I still got silica up here in my bowl, so I'm going to pour a little bit more solvent, just a bit, to try to wash that down. It's okay if that silica ends up on top of my sand. I just don't want it in my bowl. Yeah, that should do. Now we can let this drain. I'll bring us back when we're ready to add our load. Alright, so our column has drained. We're just about ready to add our load here. So We need to get that solvent level there to level with the top of the sand. So you know that just a little bit more. Perfect. Right there. So it's important that your load, what the crude compound that you're adding onto your column, is dissolved in the same solvent mixture, or as close as you can get it to your column. Otherwise you get weird streaks in your column and you get a really poor separation. So when we add this, we want to do this by pipette, adding our load to the column. What I want to do it is, I find it's good to kind of gently squeeze your pipette and go around in a circle and maybe carefully drip some into the center. We want it to be as even a layer as possible. And we want it to be all on there. Now that we've got our load on the column, we want to open it again. And then we want this level, the level of the kind of the volume of our load, to be below the sand before we add any more solvent to our reservoir. And that will ensure that we don't get any compound dissolving back up into the reservoir bowl and messing with our separation. It's important that we don't let our column go dry. We need to fill it now that we've got that start. Again, we want to do this carefully and not disturb our layers. We disturbed our sand a little bit. Fix our sand a bit there. You can see we've gotten our load onto the column. A little bit didn't quite make it through before I needed to fill it because I didn't want it to run dry. You cannot let our column run dry. You'll get channels in it and it will give you bad separation. So I'll let that loop through and then refill when it gets closer to the sand again. So if I'm running the column just like this is under gravity because I'm not pushing anything through to make the column move faster. Flash column is when you use something like this to push air through the top into the top of your column to help kind of need to use the air pressure to move your column faster. You have to be careful with that. Sometimes it won't work if your column, if your separation isn't good or if your column parameters aren't quite correct. A flash column will not separate your compounds properly, and that takes some trial and error to figure out. This column, it should be okay to do. Use some air to push it. You'll see that the solvent coming out of the bottom comes out much quicker when you do this. And you might even see the bands move through the column faster as well. Oh yeah, definitely. Depending on the nature of your compound, you might use a different material other than silica. Alumina is another common one to use. So silica can be slightly acidic, and alumina is typically either neutral or slightly basic. So depending on the nature of your compound, you might want to choose a different column medium. Also, it's important that you probably won't want to do a column on really polar molecules, as they can stick to your column and never come off. Also, air sensitive and water sensitive compounds are difficult to do columns on. Air sensitive columns can be done under an inert atmosphere, but it's pretty difficult. So keep that in mind if you ever are considering doing that. It will take a considerable amount of preparation to make it work. You can kind of start to see the different colors of bands here. So we've got kind of a yellow one here, some orange in between, and then a pink band at the top here. We'll be collecting the yellow band. There's a fluorescent green portion I'll show with a UV light here in a second, and that will be the portion that we'll be collecting. If you don't know the parameters of your column, you'll want to collect your fractions in test tubes, and I'll get a test tube rack. Turn that off. So yeah, if you don't know the parameters of your column, or how well it's going to separate, or what part you want to collect, you should probably collect in test tubes, separate fractions as you come off your column, and then you can test them individually by TLC, which we won't go into today, to figure out which compound is the one you're looking for and know which portions of your test tube that you can combine and for separation. You know, when you ultimately rotovap everything away to get recover a solid material. Additionally, if you don't really know exactly how your compounds are going to move through your column, you can start with lower polarity solid mixture and increase the polarity gradually as you go. So increasing, in this case, the ethyl acetate portion for this column would accomplish that if we didn't know that well about how to separate these compounds. So I mentioned before, for this column we want to collect the fluorescent green portion. So I'm going to go ahead and turn off the hood light here. And then I've got a UV light here. Hopefully this shows up well on camera. And you can see, you know, this yellow and orange band in the center that's coming kind of out first is a fluorescent green, and then the pink portion doesn't have any fluorescence, and then there's something that's fluorescent blue that has stuck in the silica right below the sand and will not move through the column. As you can see, our fluorescent green kind of cuts off there, so we haven't even begun to elute our compounds yet, but we will be shortly. And then, depending on, again, what's on your column, you need to maybe check by TLC, especially if they're all in colorless compounds and you can't see them physically on the column like you can with these ones. You'll need to check your eluent by TLC to know when they're coming out. So we're just about ready to start collecting. Let's actually check with the UV here. Yeah, we don't have anything fluorescent coming through just yet. Not that I can see anyway, but there is the fluorescent stuff just about to reach the bottom of the sand layer here. So because we know that our first compound is the one we want, and there's nothing else in front of it, or at least we're going to throw away anything that might have come out in front of it, we can just go ahead and collect directly into a round bottom to rotovap away the solution. So I'll bring us back in when we've collected some. So we're collecting away. I had to move the round bottom because I filled it up. So I've got that Erlenmeyer there in place to collect. And then over here on the rotovap, I've got my first portion of solvent that I've collected with my compound in it. And I'm going to turn on the vacuum pump here and start rotovapping. So we have reached the end of our collection. Our last bit of green is pretty well through the column. I don't want to get any of this pink in my thing, so I'll sacrifice that little tiny bit to keep a nice clean compound. So we'll remove that. We'll set that aside to rotovap. I'll just get another Erlenmeyer here, And then to kind of close out a column, you want to flush out the rest of the solvent. So I'll go ahead and open that back up, turn on my air, and we'll flush it out. So see if we can get this to go through. And we'll be pushing this well past all the silica, and you'll see the silica kind of crack and dry out as it goes, and that will make cleaning the silica out quite a bit later. Quite a bit easier later. Anyway. And then after we're done with this, we can just suspend this column upside down over a beaker and let the silica dry the rest of the way, so that we'll be ready to clean it up, or clean out the column. Now, if we were interested in the pink compound, we would of course want to keep collecting and collect that band. But we're not, so we're not going to. And you see now, silica's drying out. Pushing the rest of that solvent through. That on our waste. Let's suspend this column here. With the stopcock open over that beaker. And we're done. After, of course, we wrote about this.